Ever since I was a little kid, board games fascinated me. But as I kept growing up, I realized finding mathematical patterns in nature fascinated me even more. So I wonder, can we connect the two of them? So what is Hex? Hex is a two-player strategy game that is played on an n cross n board where the players keep alternating. The goal of the game is to connect the one player's side with the appropriate opposite side. Right? I know it sounds a little complicated, but how about I demonstrate a game to you to explain the rules better? Harsh, could you join me for a game, please? Right. So this is the n cross n board in which the game is played, right? So I'm player 1, so my move is represented by the letter 1, and you'll be player 2 and your move is represented by the letter 0, right? So my goal of the game is to connect this side of my board to this side, and your goal is to connect this side of the board to this side of the board, okay? So what does it mean to say that two pieces in the board are connected, right? So two pieces in the board are said to be connected if there's an edge between those two pieces like this, so these two are connected, and if they have the same symbol inside them. So there's 1 and 1 here, then these two are connected. There's 1 and 1 here, they're connected. There's 1 over here and 0 over here, then those two pieces are not connected, right? So did you get the rules of the game, Harsh? Okay, wonderful. So I'll start playing first, all right? Right. So if you notice, you can see that I've already made a connection, right? So this is my winning path. But you know what? Let's continue to play the game because I don't like to leave things incomplete. So Harsh, so let's just. Cool. So we'll fill the board. Thank you so much, Harsh. No hard feelings, right? All right. So what was the point of the game? I had won already, but despite that, I was filling up. And you can still see that the 0 still hasn't connected his side of the board with the opposite side, okay? Is that just a coincidence or, well, let's see. So, you know what? Let me represent this hex game in this form. So, here, so what was the game? The game basically is to find a path, right, from this side of the board to this side of the board, or 0 should find a path from this side of the board to this side of the board, right? So now I had 1 already, so let's just represent my path as like this, right? So this, and 0 was trying to form something, right? Right. So I've connected my side already. Now, no matter how hard 0 tries, you can see that he has to intersect with my path and he cannot go to the other side. So what does this mean? This means that if one player has won the game, and even if you continue to fill all the other entries with whatever 0 or 1, you can see that player 1, the one who has won, remains the winner. Okay? Right. So now you may be asking, well, what if the game ends up in a tie? Then what would you say? Well, here's the fun part. In a game of Hex, no draw is possible. There is always a winner, and this is called as the Hex Theorem. I know it sounds really simple, but it's a very, very powerful theorem in mathematics. You can prove that this particular theorem, that the game of Hex cannot result in a draw, is equivalent to powerful theorems like Brouwer's fixed point theorem. Right? We're not going to talk about those particular connections. We're not going to prove the Hex theorem. We're not going to prove its equivalence with other mathematical theorems, maybe for some other time. But you just have to take my word for this, that there will always be a winner in this particular game. And once that player has won, even if you fill it up with the other entries with any other thing, you can see that the winner remains the same, right? So, is there any other reason why you think I could have filled it up? Or why did I fill it with 1s and 0s, right? So if you play the game of Hex online, or if you download an app and you play it, you'll see that it's mostly a red piece and a blue piece that are playing against each other. But I converted this into a 0-1 game, right? Why did I do that? So if you look at this, I can convert this whole thing into a 5x5 matrix, right? A 5x5 matrix where each entry is either a 0 or a 1, right? And that kind of now takes us into the realm of mathematics. So what we can do is, we can actually count the number of games where the first player wins in a hex game, right? So let us create something called hex matrix. So what is a hex matrix? A hex matrix of size n is an n cross n matrix that represents a hex game, right? So how would I represent this? So here we can see this entry as the first as the entry in the first row, first column, first row, second column, first row, third column, second row, first column, and so on and so forth, right? So what would be the representation of this? This is a 5 cross 5 matrix. So it's 1, 0, 1. Right? So this is one hex matrix in a 5 cross 5. Okay? So you have a hex matrix of size 5. Now let's create something called as hex function. So what is a hex function? So the hex function I define as a function from the natural numbers to the natural numbers, where h of n is defined as the number of hex matrices where the player 1 wins. Okay? So now n can range from, n is a natural number, so it can range from 1, 2, 3, 4, 5 and so on, right? And in this video, what we're going to try to find out is, we're going to try to find out h of 1 and h of 2, okay? So the game of hex is usually played on 11 cross 11 or 12 cross 12 or till 19 cross 19, alright? So but today we're going to keep the math simple and we're going to try to find h of 2, okay? Right. So let's first try to see what does h of 1 mean. So h of 1 represents just a 1 cross 1 matrix where player 1 wins. So in this entry you can have 1 or 0 entering, but since the first player plays first, once he's put the move, he's won already. So it's done. There's nothing else that can be done. So h of 1 is 1. Okay. So now let's find h of 2. So h of 2 represents all those hex matrices where player 1 has won. So first, before we're trying to calculate, let's try to see how many hex matrices are possible in a 2 cross 2 matrix, right? So we have 2 cross 2 matrix, meaning there are 4 entries, right? So how many, first of all, how many binary matrices are possible? Let's calculate that. So each entry can be 0 or 1 and there are 4 entries, so total possible such matrices will be 2 power 4, okay? But not all of them are hex matrices. For example, well, this is not a hex matrix, right? So what will a hex matrix be in a 2 cross 2? If we see, we know that in a 2 cross 2, the first player plays first, second player then plays, third player plays, and then second player plays again. So that's it. So you filled up all 4 of your entries. You can see that always the number of first player will play 2 moves and the second player will always play 2 moves again. Unlike in that particular matrix, if we calculate, we can see that here there are 25 entries, right? So there should be 25 moves in total. So the first player can place first, then the second player, third player, and again the second player, and so on. He will play the 20. So we can see that the oddest move is always played by player 1. So he plays till 25, meaning there are 13 moves that player 1 makes, 12 moves that player 2 makes. So player 1 always has an extra move to play, right? But unlike on an even cross even, we can see that the number of moves played by each of them is equal. Okay, so now you have 2 1s in this matrix and 2 zeros that should be entered in the matrix, and you have 4 entries. So number of possible hex matrices for 2 cross 2 is 4C2 because you have 4 entries and you need to choose 2 1s. This is the same as choosing 2 zeros, so it's 4C2. Okay, perfect. So these are the total possible hex matrices of size 2 cross 2, right? And from these we have to now calculate the number of matrices where 1 has 1, meaning h of 2 is what we have to compute, right? So we can see that how many paths are possible from one end to another, right? One connection is like this, the other connection is like this, and the other connection is like this. And since you've filled it up with 2 entries, the rest of the entries have to be filled with zeros because, like I said, 2 moves for 1 and 2 moves for 0, right? So these are the only possible matrices in a 2 cross 2 matrix where 1 is 1. So we have h of 2 equal to 3. So what about the number of matrices where 0 has 1? How do you calculate that? Well, one way is to calculate, you have 4C2 number of matrices in total and you have h of 2, and we know that player 1 has to win or player 0 has to win. One of them has to win, and we found all possible ways in which 1 can win. So the number of ways 0 can win will be 4C2 minus 3, which is 3. Oh wow, they're actually equal. Is there a coincidence? Well, let's see. How else can you think about this, right? We can actually show that they're actually equal in a different way instead of computing this. So you can see that 1, 0 winning is the same as if you flip this entry over here, and this entry over here, and this entry over here, this entry over here. What would you get? You'd get 1 goes here, it goes here, 0 goes there, 0 goes there. There we go. Your matrix. 0 is 1. There's one path. Similarly, if you do the same thing over here, you'll get 1 goes here. There we go. So there's always there's a symmetry in an even cross even matrix. You can prove that for H4 also it will be equal number of moves of both of them. So in H4 you'll get that you have, how many moves do you have? You have 16 entries, out of which 8 of them should be played by 1 and 8 of them should be played by 0. But we know only half the number of these is H4, right? So what about for odd cross odd? So odd cross odd, the calculations get a little tricky. So I'm going to leave that to you, and why don't you give us the answers for H3 in the comments section, and we'll tell you if that's the right answer or not.